Good afternoon. I'm Saritha Kumari, Assistant Professor Triple E Department, working in Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today, my topic is problems on capacitance of transmission line. So, this topic mapped to course outcome 1. So, first problem: a single phase transmission line has two parallel conductors 3 meters apart. Radius of each conductor being 1 centimeter. Calculate the capacitance of the line per kilometer. Given epsilon naught value, it's a well-known value 8.854 into 10 power minus 12 farad per meter. So they have given single phase transmission line. It has parallel two conductors which are separated by distance of 3 meters. That means we know that small d, so distance between the conductors is taken with either small d or capital D. So it is given 3 meters. So that means 300 if you write that in centimeters. Because the radius of conductor is given 1 centimeter, it is given in centimeters. Okay, that's why distance also mentioned in centimeters. So radius of the conductor given 1 centimeter. So calculate the capacitance of the line. So capacitance of the line they asked. So it's last in my last lectures, previous 2-3 lectures, we have seen the capacitance expression. Okay, so for a capacitance of the line, total line, so that is given by capacitance between the two conductors. Expression is C is equal to pi epsilon naught by log base E d by r, right? So here substitute epsilon naught value. Okay, pi into 8.854 into 10 power minus 12 log base E, small d is okay, both d and r substituted in centimeters. So 300 by 1. So the value is calculated. So using scientific calculator. So 0.4875 into 10 power minus 11 farad per meter. But they asked capacitance of the line per kilometer. So if we write the value per farad per kilometer, it value becomes into 10 power minus 11 into 10 power 3, right? So it becomes 10 power minus 8. So 0.4875 into 10 power minus 8 farad per kilometer. So for simplicity, write down means generally capacitance we write in microfarads. So if we write this in microfarads per kilometer, the value is 0.4875 by 10 power minus 2. So this is a value for the given problem. Okay, capacitance of the line. Next problem, a three-phase overhead transmission line has its conductors arranged at the corners of equilateral triangle of 2 meters side. Calculate the capacitance of the each line per kilometer. Given diameter of each conductor is 1.25 centimeter. So here, see that the three-phase line, it is given three-phase transmission line, and the conductors are arranged in the form of equilateral triangle. So equilateral triangle means we know that distance between the, any two conductors, if we take, that is same. So the three conductors ABC, let us say, so the distance between any two conductors is 2 meters only. 2. Okay, so now diameter is given 1.25 centimeters. So diameter is given in centimeters. So that means radius we take from that 1.25 to 1.25 by 2 is equal to 0.625 centimeter, and the distance between the conductors is taken. Okay, 2 meters means write that in 10 centimeters, 200 centimeters. Now calculate the capacitance. So we know that for a three-phase line, capacitance expression is same as single-phase line. single phase line, only the thing is in the log base d by r, only the d varies. Okay, so d means distance between the conductors. So this is given equilateral triangle. The three conductors arranged in equilateral triangle. So small d is given by cube root of the, okay, cube root of, so small d is given by cube root of d1, d2, d3. All are same, right? 2 meters only. So it becomes, okay, d only. So I'm talking this d. Okay, it may be d also. Sometimes we can say so that d becomes simply because the conductors are arranged in the equilateral triangle manner. So becomes simply 2 meters. So if we write that in centimeters, 200. So here they are asked to calculate the capacitance of each conductor. Okay. So capacitance of each conductor means capacitance between the conductor and the neutral. Okay. Capacitance between the one conductor and neutral, that is given by expression 2 pi epsilon naught. Okay. So 2 is there. So 2 pi epsilon naught by log base c d by r. Okay, substituted epsilon naught value, d value in centimeters 200, r value is 0.625. So this is the farads per meter, the expression capacitance. Okay, now they asked per kilometer, right? So into 10 power 3, it becomes point, okay, 0096 into 10 power minus 6 farads per kilometer. Okay, again we write capacitors generally in microfarads. So if you say that in microfarads, okay, 0.0096 microfarads per kilometer. Now a three-phase 50 Hz 66 kV overhead line conductors are placed in a horizontal plane shown in figure. So three-phase line they are mentioned, and that is at operating voltage of 66 kV. So that is given line voltage. Okay, that is nothing but line operating voltage. Now the conductor diameter is 1.25. So radius from that we consider 1.25 by 2. Then if the line length is 100 kilometers, they are telling line length 100 kilometers. Okay, calculate first bit capacitance per phase and second bit charging current per phase, assuming complete transposition of line. So they mention the line is transposed. So now we know that in case of three phase line, the capacitance per phase expression is given by, okay, what is the expression? Log of pi epsilon naught by capacitance per phase. So it is 2, right? 2 pi epsilon naught by log by c d by r, where d is nothing but three phase line, right? So cube root of d1, d2, d3. So from the diagram we clearly see that the distances are between the first conductors is different. Okay, first two conductors 2 meters, next to two conductors 2.5, and the third and first conductor it is 4.5. So that is those are the distances they have given. So the d is given by calculated cube root of 2 into 2.5 into 4.5. So which is 2.82, 2.82 meters. So come to the substitution, 2 pi epsilon capacitance per phase. Okay, so 2 pi epsilon naught by log base c d by r. So d is calculated. Okay, this d is calculated. So now r also substituted. So substituted d is in centimeters, right? So that's why 282 by 0.625. So epsilon naught value substituted So finally, this will be the answer per kilometer. This is a 0.0091 microfarads per kilometer. But they mentioned the length of the line is 100 kilometers. So mention this capacitance value for 100 kilometers. Okay. So 0.0091 into 100, it will become 0.91 microfarads. Now, charging current. Now, charging current is given by, we know that from Ohm's law, basic Ohm's law. Okay, I is equal to V by R, but here what is the resistance? Here for us capacitance. So V by XC. So for phase value, right? So charging current for phase we want to calculate. So voltage value also for phase value. So they have given 66 kV line voltage. So per phase value means 66,000 by root 3. So into 1 by, we know that XC is 1 by 2 pi FC, right? So it will become 1 by XC means 2 pi FC multiplied, okay, with the 66 kV by root 3. So substituted, given operating frequency 50 and this C value calculated. So substituted that and finally calculated charging current 10.9, which is okay, which is the answer. Now next problem, figure shows completely transposed 50 hertz to 50 kilometer long three phase line. Okay, they mentioned three phase line. The length of the line also given to 50 kilometer. Has the horizontal phase spacing with 10 meters between the conductors. Okay, between adjacent conductors. Okay, so in the clearly diagram given, it is how the 10 meters is, and then if the outside radius is 1.2 centimeters. Okay, they mentioned the radius of the conductor is 1.2 centimeter and the line voltage is 220 kV. Okay, now determine the charging current for phase. Charging current and the total reactive power in MVAR means, okay, megavolt amperes. Okay, supplied by the line capacity. Okay, so first we calculate the charging current because we know previous problem also we have seen how to calculate the charging current per phase. So uh, so here for that first we calculate the capacitance side, right? Capacitance for phase 2 pi epsilon naught by log base E d by r. So here see, look at the d, how to calculate the d here because we have double circuit, three phase double circuit line. So this is, so this one they mentioned, right? Three phase bundle conductor line. So what is the expression? 2 pi epsilon naught by log base E for double bundled conductor like this, we have dm by ds, right? So here we have to first we need to calculate the uh, first we need to calculate the what is dm, mutual gmd, ds is a self gmd. Actually in case of capacitance we have ds is nothing but simply the radius of the conductor. Okay, whereas in case of inductance capacitance, that is multiplied with the 0.7788, right? So but in case of capacitance, that is simply the radius of the conductor. Okay, it depends only with the radius. Okay, and then the distance between the subconductors in the one phase. Okay, in the phase itself. Okay, so first we need to look at this. Okay, these two, then we go to the, okay, capacitance calculation. So the conductor is like this given. Okay, the distances between the two between the phases is given 10 meters. Okay, with the distance like this, and the distance between the subconductors in the phase is given zero point 0.4. So now how to calculate how to calculate uh, first ds. So as I mentioned here uh, it is given as simply see that this is ds, this is dm. Okay, so now the r naught is given how much? The r naught, the radius of the conductor is given 1.2 centimeter. Okay, so uh, so 1.2 centimeter means meters 1.012, and the distance between the conductors is subconductors zero point 0.4 meters. So now ds is given by simply here how we calculate, that is given by, okay, because conductor have the subconductors, we know that how to calculate the ds, fourth root of d a a d a a dash d a dash a d a dash a dash, right? Okay, yes or no? That is how we calculate the self GMD, right? So with respect to conductor itself. Now, here, uh, what is DAA? DAA dash A dash, both are equal to radius, right? Next, DAA dash is DA dash A is equal to zero point 0.4, right? So, this become finally square root of R into zero point 0.4. Yes or no? This become, because r square zero point 0.4 square whole power 4, 1 by 4, right, becomes 1 by 2. So finally what we will have here, square root of the radius of the conductor multiplied with the distance between the distance between the subconductors. So 0.012 into zero point 0.4, so which is 0.0693 meters. Now coming to mutual GMD. Virtual GMD, how we can calculate? Directly we can calculate, okay, that means distance between the phases DAB, DBC, DCA. Okay, from the diagram DAB is 10 meters. Okay, this is 10 meters, this is 10 meters, right? Distance between the conductors C and A is 20 meters. So that is how directly we can calculate DM. Okay, mutual GMD, or here they are calling it as D, they are telling it as D equivalent. But better to use the same terminology whatever we have used in the inductance calculation. So this is DM. Okay. Now the same DM can also be calculated like this. You can see here. Okay, from here to here. So here, how can we calculate? So we know that this is equal to cube root of DAB, DBC, DCA. Because each conductor has a subconductors, so DAB is given by fourth root of DAB, small DAB dash, small d a dash b, small d a dash b dash. So DAB dash, all everything from the distances are given. Okay, so this is 10, 10, DAB dash 10.4, DA dash B is 9.6. Yes or no? From the diagram, previous diagram. AB, distance between the AB is how much? From here to here. Okay, so this is 10 meters from here to here. Okay, so now this is added, but this is the same length subtracted. So finally, whatever it may be, DAB is 10 only. Now DAB dash, DAB dash, how we calculate? Okay, from here to here, right? So so from here to here 10, but the AB dash means this value added, this value added. Okay, so means this is zero point 0.4, half of that is zero point 0.2, right? This value also zero point 0.2. So DAB dash is equal to how much? 10.4. Okay, 10.4. The same manner DA dash B also. It becomes okay 9.6. Same thing from the given diagram. Okay, next A dash B dash. If we check the diagram, it's also 10. It's also 10. So anyway, fourth root of this gives the 9.99 meters. Next, DAB is also same as DBC. Okay, because DBC is what? Same manner, fourth root of Okay, small d BC, BC dash, D B dash C, okay, B dash C dash. So that is same value. Okay, look at the diagram, it will also the same as the distances. Okay, and finally gives a 9.995 only. Okay, okay. Now DCA, capital DCA. So capital DCA is given by fourth root of DCA, small dca dash, okay, small d c dash a, small d c dash a dash. So DCA is how much from the diagram? 20 meters. Okay, yes or no? CA from here to here to here. Okay, that is 20. Okay, next DCA dash also same manner calculated, which is obtained as 19.6. Okay, like that. It is finally obtained as, okay, how much? This value 12 point. Okay, this is 19.96. Now, finally calculating DMR D equivalent. Okay, cube root of 9.9 into 9.9 into 19.9, which finally gives 12.5. So this is another way of calculating DM, sorry. But directly also we can calculate like this. Both are C. You can check the answer. The values are same. Okay. So this is this whole explanation based on DM concept, right? When a conductor, when the phase having subconductors. Okay, because here we see the conductors are arranged in a horizontal manner. So like that's why they calculated directly like this also. Now coming to capacitance. So here this is a log base 10. Okay, but we have the expression 2 pi epsilon naught by log base C capital D equivalent by ds, right? So if we substitute that, answer is obtained as this much. Okay, but they have given the length of the line to 50 meters, so multiplied that. Finally, answer is 2.67 into 10 power minus 6 farads. Okay, for this total length given. Now, finally, we want what we want. We want the charging current per phase, right? So, same manner like previous VPH by, okay, XC. So VH is given, okay, line voltage is given by root 3, okay. So XC is given by 2 by FC, right? It goes up. So substituted, okay. So this is how the magnitude calculated. Only magnitude we want, so don't bother about this J operator. Okay, we want only the magnitude. So that's why IC is equal to voltage into 2 pi FC. Okay. Next, they ask reactive power. Okay, reactive power. Okay, we know that power expression is V square by R. Here we have XC, right? So V square into 2 pi FC. Okay, so that is how they calculated the reactive power. Okay, they calculated the reactive power. Okay, so what they ask? Three phase total reactive power. Okay, total reactive power means for the three phases they ask. So that's why here they considered for the three phase the voltage. The voltage is what here? Line voltage. The voltage is line voltage. Okay, so finally this is the answer. Okay, there is one more problem. There is one more problem. Calculate the capacitance to neutral per kilometer with and without considering the effect of Earth. Okay, they ask to the capacitance, calculate the capacitance to neutral per kilometer with and without considering the effects of earth. So both two things they ask, with considering the effect of earth, without considering the effect of earth. Okay. Uh, then radius of conductor given, spacing between the conductors is given, and height of the conductor above the ground is given 8 meters. Then they also mention that compare the results. Okay, now, so the this thing we know that when the effect of earth is considered, the expression for capacitance we have. Okay, so far the problems we have seen, that is neglecting the effect of earth on capacitance. Okay, so now also we know that uh, consider the effect of earth on capacitance. The expression is, in that case, the expression for capacitance is given by, okay, pi epsilon. This is, they ask neutral, capacitor neutral, right? So 2 pi epsilon naught by 2 pi epsilon naught by log base. This is they mentioned in log base 10. Okay, in numerator. So that's why, anyway, the term is here only. This is the additional term, right? In the denominator, log base C capital D by R into 1 plus D square by 4 H square whole power 1 by 2. That is the only additional term. Okay. So, uh, so that is, we need to remember that. So microfarads per kilometer, this is the expression given, microfarads per kilometer. Okay, so anyway, no need to remember like this. Basic expression 2 by epsilon naught by log basic capital D by R into 1 plus D square by 4 h square whole power 1 by 2 farad per meter. Okay, basic expression only, we can substitute the same values. Okay, at the end we can calculate that for per kilometer, right, into 100. Anyway, here they directly considered this expression. This expression is simplified capacitance for microfarad per kilometer. So in this, they substituted for a small r is 0.01 given value, and distance of separation 3.5 meters. Okay, and height of the conductor above the ground, that is small h, is 8 meters. So substituted here, look here, capital D substituted, then radius substituted, and h also substituted. Finally, the answer we have, okay, this is given as point 0. Here I can see 0.00955. Now, uh, neglect the effect of earth without considering the effect of earth. So, this is the expression we have. So, 2 pi epsilon naught by log base C capital D by R. If they are writing in microfarads per kilometer, that expression is simplified, and this is the simplified one. In that, they substituted answer. Okay, capital D and smaller are substituted, and the answer here is 0.00951 microfarad per kilometer. Now, because they ask you to compare the results, so that's why they are just shown as earth with the effect of earth, without the effect of earth. So with the effect of earth, 0.0095 by 955 by 0.00951. So this is 1.0042. So the percentage of earth, that means the percentage of earth increases capacitance by only 0.42%. Okay, that is the meaning, right? So the capacitance of the effect of earth um, increases the capacitance value by only 0.42%. So which is very negligible value. So that is a conclusion. Okay. Okay, then these are the problems based on the capacitance. Thank you. And these are my references. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.